Okay, this is chapter 4, part 5. All right, so we've talked about that least squared regression line, and now what we want to do is talk about how we can make predictions. So both when or with that least squared regression line and without it. Because there are times that we are not able to use this equation, and we'll talk about that in this video. All right, so I left all of the notations that I made previously on this slide just so I could do a quick recap. So this is from our made-up data. We saw that our R value was less than the critical value, so our y hat, our equation, our least squared regression line, is useless. So we can't use it. So what do we want to use instead? Well, let's take a look. All right, so just to state again, so here, this is my my made-up data that I had. I've got an R value of negative 0.307. We saw that for even though this doesn't say it, this was I wish it told us this. That would be really handy to have the n value. But this was an n of 10, and I had 10 data points in there. So this was not a strong enough relationship for us to believe that there's a linear relationship between these two variables. And therefore, y hat is, I can't use it. So when we can't use y hat to predict, then the best prediction is the mean of the y values. And of course, in the way we'll write it is y bar. But what we'll do is we'll do just like we did in chapter 3. We'll do our 1var stats. But we need to do 1var stats for L2, because L2 is our y values. So let's see what that looks like. There we go. So here's our 1var stats. And for list, you're going to do L2. For your frequency list, you're just going to leave it blank. All right. And then that means that our our mean of our y values, y bar, is going to be on our calculator x bar. And I know that's confusing. So with this made up data, if I was trying to predict something for any x value, so let's see, switch my pen color again so it doesn't get confused. So for any x value, the best predicted y value in this case would be 20.6, and then whatever units. We always want to put our units in there because this was too low. Now, if our R value is greater than the value given in the table, then we're able to use the y hat. All right, so now that we know that we can use y hat, we said that y hat, and again, I'm just going to round to 3 decimal places, was 0.012x plus 5.527. So if we want to predict the drilling time, if drilling starts at 130 feet, then of course our distance or beginning distance was x. So this simply means that x equals 130. Since I can use my equation, I'm simply going to plug that in. y hat will equal 0.012x plus 5.527. Now, if you want to use the exact values and not rounded ones like I have written down here, then what you could do is use the trace option in your calculator, and that will give you the exact number without any rounding. But I'm pretty sure every time I've worked through these before, our calculator is fine, or excuse me, our MyLabs Plus homework is fine if we use the rounded values that we wrote down or typed in for our regression line. So using the 0.012 should be okay. So I'm just going to multiply by 130 because that's where I put my x in. So 0.012 times 130, and then I'm going to add 5.527. When I do that, I get a y hat of 7.087. Now, remember, this x value was in feet. Our y value should be our time, and that was in minutes. So, our predicted value, if drilling time, the predicted drilling time, if drilling starts at 150 feet, it should take about 7.087 minutes to drill an additional 5 feet. All right, so in this next part, we are actually wanting to know if the observed drilling time at 130 feet is that above or below average. Well, that's what our y hat value is. So when we're talking about this y hat value that we found, the predicted value is also what we would consider the expected value. And if you remember from chapter 6, we actually used that term expected value to mean the same thing as the mean or the average. So if we want to know if the observed value, the observed time, and I've got that table on the next slide, so we'll look at that because I don't remember what it is either. But we want to know if that observed value is bigger or smaller than this predicted value. So let's take a look. All right, so here's our table of data again. And again, we're looking at when the drilling began at a depth of 130 feet. So there's that value. And we want to know if the observed time is below average or above average. And once again, this is what we are considering to be average. That's that expected value. As predicted by the equation. And in this case, since 6.93 is less than 7.087, then we would say that the observed value is below average. So they were actually able to drill 5 feet faster than believed. Should have been what was expected.